Hello, everyone. We're working through an introduction to statistical methods and data analysis by Ott and Longnecker. This is chapter 12, part 4, multiple linear regression using R. So we're going to go back to some things that we learned earlier in the chapter and remind ourselves that often we might use our regression model to estimate the mean response of a group for a new prediction, or we might predict future values of one particular person or one particular thing. So the function predict in R can be used to make both confidence intervals for the mean response, but it can also make prediction intervals for a single response. So the only difference is choosing the option to be confidence versus the option to be prediction. Okay. If we want to change our alpha level, we just need to specify the confidence level. So by default, it's going to be at level 0.95 or 95% confidence interval or prediction interval. But if you would like to change that level, you can by just specifying the level equals 0.99, for example, if you wanted to do a 99% confidence interval. So if we wanted, we could fit a model of our salary, our number of employees, profit margin, and IP cost. And what we can do is we can get a confidence interval for the mean response at a particular value of X1, X2, and X3. So this is very similar to what we did in chapter 11, but now we have multiple X's instead of a single X. So what we do is we use this predict function. So we use predict, then we fill in the model fit. So for example, if we had said fit.1 gets LM of salary, all caps, right? Salary follows number of employees plus profit margin plus IP cost, right? Data equals data. Then I can use predict, right? Predict fit 1. And what I'm going to do is I'm going to tell it the data set, data equals data. And then I'm going to feed in a new data frame. So I write data.frame. And I fill in the number of employees. So we're going to do this for the number of employees being equal to 85, the profit margin being equal to 20, and the IP cost equal to 8. Okay, and then since I want a confidence interval, I'm going to say interval equals quotes confidence. And if I want this at the 95% level, I'm going to say level equals 0.95. All right. So by doing this, this will give me the y hat value. So the fit is the y hat value, right? So y hat in this case equals 29.51404. Okay. And then the confidence interval, the 95% confidence interval for the new mean response, right, is 29.26 up to 29.76. Okay, remember that we're measuring this in thousands of dollars for the starting salary. So we would say, we're 95% confident that the average salary for a company or for a group of companies where the number of employees is 85 people, the profit margin is 20, and the IP cost is 8, we would assume that the starting salaries of the beginning programmers or analysts should be between about $29,263 and $29,765. All right. If we're doing a prediction interval, y hat still is going to equal that 29.51404. But the 95% prediction interval for a single value, for a single salary, right? Not a group of salaries, just a single salary, is going to be 27.500 up to 31.528, right? So now what we're saying is that we're 95% confident that for a new prediction for a single person who is being hired at a company with 85 employees, a profit margin of 20, and an IP cost of 8, we would think that their starting salary is between $27,500 and $31,528. So the prediction interval is always going to be wider, right? Or larger. And why is it larger? Well, if we're making a prediction for a single person's salary, there's going to be more variability than if we think about the prediction for many employees hired under this scenario. But what's their average salary versus what's the salary of one single person who's going to be hired? So overall, prediction intervals are always larger. But essentially, to get the prediction interval and the confidence interval, you can use the formulas that are in the book, but I find it much easier just to use the code because it's going to be just like one line of code. And the most important thing at the end of the day then is, what are we actually predicting? Well, if it's a confidence interval, we're predicting the average response, in this case, the average salary of a group of people hired at a company, hired at companies in this scenario. Whereas the prediction interval is saying, what is the likely values of a single employee being hired under this one single scenario?